This is a hypothetical scenario based on public information about strategic aviation capabilities, Arctic defense doctrine, and sensor network integration. It is designed for educational purposes only and does not reflect any specific classified operation or real-world event. At 0930 hours on a frozen February morning over the Barents Sea, a radar signature appeared on Norwegian air defense screens that should not have existed. Two massive strategic bombers, Tupolev Tu-160 Blackjacks, the largest supersonic combat aircraft ever built, were climbing through 40,000 feet and accelerating toward Mach 1.8. But here is the part that made every NATO air operations center go silent. These aircraft were not displaying standard Russian Federation transponder codes. They were broadcasting joint mission identifiers, suggesting coordination between Moscow and Tehran. A strategic partnership testing the boundaries of Arctic airspace in ways that had never been attempted before. The question is not whether NATO detected them. The question is what happens when the ocean of air above the frozen sea becomes a three-dimensional chessboard where every move carries the risk of miscalculation. A Tu-160 is not just a bomber. It is a message written in titanium and turbofan thrust. At over 54 meters long, with a maximum takeoff weight exceeding 275,000 kilograms, this swing-wing giant can carry up to 40,000 kilograms of cruise missiles and fly 11,000 kilometers without refueling. When you see one, you are looking at a strategic decision already made. When you see two operating in coordination with a nation that does not own them, you are looking at a geopolitical signal designed to rewrite the rules. But signals work both ways. And NATO's response to this particular provocation would prove that the Arctic is not an empty frontier. It is the most sensor-dense battlespace on Earth. The Arctic is not silent. It is the loudest place in the electromagnetic spectrum. Every radar pulse, every satellite pass, every high-frequency communication bounces off the ionosphere, creating a dome of awareness that makes stealth nearly impossible. The challenge is not seeing the threat. The challenge is deciding what to do about it without crossing the line from deterrence into confrontation. This is where doctrine meets physics and where the hidden costs of power projection reveal themselves. So to understand why this flight mattered, you need to understand the geometry of the Arctic. The North Pole is not a barrier, it is a shortcut. The Great Circle route from Moscow to North America passes directly over the Arctic Ocean. During the Cold War, both the United States and the Soviet Union positioned their early warning radars to stare north because that is where the missiles would come from. Today, those radars are still there. They have been upgraded with phased array systems, space-based infrared sensors, and over-the-horizon networks that can detect aircraft signatures at ranges exceeding 3,000 kilometers. The Tu-160 flight was detected the moment it left Russian airspace. But detection is only the first step in a kill chain that must balance speed with restraint. Now, the Norwegian intelligence service operates the Globus 2 radar at Vardø, a massive installation that looks like a giant golf ball perched on the edge of the Barents Sea. This is not a weather radar. It is a space surveillance and early warning system capable of tracking objects in low Earth orbit and high-altitude aircraft simultaneously. When the Tu-160 formation entered its coverage zone, Globus 2 did not just see them. It measured their velocity, altitude, heading, and radar cross-section with enough precision to identify the specific variant of aircraft and estimate their payload configuration based on flight performance. That data was transmitted via fiber optic links to the NATO Air Command and Control System, a network that fuses information from radars, satellites, and airborne sensors across 15 nations in real time. Within 90 seconds, every Allied air defense commander from Thule Air Base in Greenland to Keflavik in Iceland had the same tactical picture. But here is the hidden trade-off. Total transparency creates decision pressure. When everyone sees the same threat at the same time, the expectation for immediate response increases. The Norwegian Quick Reaction Alert fighters, F-35A Lightning II aircraft were airborne within 8 minutes. But launching interceptors is not the same as making contact. The F-35 is a 5th-generation stealth fighter designed for sensor fusion and information dominance. Its AN/APG-81 active electronically scanned array radar can track multiple targets while remaining undetected. But in the Arctic, weather and electromagnetic interference can degrade even the most advanced systems. The pilots had to rely on data links from the E-3 Sentry airborne warning and control system aircraft orbiting over the Norwegian Sea to guide them toward the intercept point. That dependency is the price of networked warfare. You gain speed and precision, but you lose autonomy. At the same moment, aboard the USS Gerald R. Ford Carrier Strike Group operating in the Norwegian Sea, the Combat Information Center received the same alert. The Ford is equipped with the Cooperative Engagement Capability, a system that allows ships and aircraft to share targeting data and create a unified air defense picture. The question facing the strike group commander was not whether they could engage. The question was whether they should. Shooting down a strategic bomber in international airspace would be an act of war, but allowing it to continue unchallenged would signal weakness. The solution was to demonstrate capability without crossing the threshold of lethality. That meant deploying assets that could shadow, jam, and psychologically pressure the Tu-160 formation without firing a shot. The United States Air Force E-8 Joint Surveillance Target Attack Radar System aircraft, callsign Red-Eye 2-1, climbed to 35,000 feet and activated its synthetic aperture radar. This platform is designed to track ground vehicles, but its side-looking radar can also map surface ships and detect low-flying aircraft over water by analyzing wave patterns and atmospheric disturbances. The Russians flying the Tu-160s knew they were being watched. They could see the Norwegian F-35s closing from the west and the electronic signature of the E-8 painting them from the south. But they continued their flight path, maintaining course toward the boundary of the North Atlantic Treaty Organization Air Defense Identification Zone. This was not recklessness. This was calibrated provocation, designed to test response times, sensor coverage, and rules of engagement. Then the Iranian factor entered the equation. According to the hypothetical joint mission profile, Iranian technical personnel were embedded aboard one of the Tu-160 bombers as observers, learning Russian strategic aviation procedures and gathering intelligence on NATO reaction patterns. This arrangement, if real, would represent a significant evolution in Tehran-Moscow military cooperation. Iran does not operate strategic bombers, but it does operate long-range cruise missiles and unmanned aerial vehicles. By observing how NATO detects and responds to heavy bomber penetration attempts, Iranian planners could refine their own penetration tactics for potential future conflicts. The presence of foreign nationals aboard a nuclear-capable platform adds a layer of political complexity that changes the calculus of engagement. If NATO forces down an aircraft with third-party personnel aboard, the incident expands beyond a bilateral issue into a multi-nation crisis. Now this is where the ocean lies to you. The Barents Sea looks empty on a map, but beneath the surface, it is crowded with submarines. The United States Navy operates Virginia-class attack submarines in this region as part of the Submarine Force Atlantic. These boats carry Tomahawk cruise missiles and Mark 48 torpedoes, but their primary mission in this scenario is intelligence gathering. Using towed array sonar and non-acoustic sensors, they monitor Russian submarine activity and surface ship movements. When the Tu-160s entered the area, the submarines were ordered to shift their focus to the surface, using periscope depth electronic surveillance measures to intercept Russian communications and correlate bomber flight paths with surface vessel positions. The hidden cost of this reorientation is that submarine time spent watching bombers is time not spent tracking enemy submarines. Every sensor has an opportunity cost. At 09:52 hours, 22 minutes after initial detection, the Norwegian F-35s made visual contact with the Tu-160 formation. Soon the lead fighter pilot reported seeing both bombers in a loose tactical spread, with the wingman flying approximately 5 kilometers behind and offset to the south. The distinctive variable sweep wings were in the forward position for high-speed cruise. No external weapons were visible, suggesting the cruise missiles were loaded internally in the twin weapons base. The Norwegian pilot maneuvered his F-35 to a position 1,000 meters abeam of the lead Tu-160 and held formation. This is a standard intercept procedure designed to communicate presence without aggression. The Russian crew could see the F-35 through their cockpit windows. The Norwegian pilot could see them. No weapons were armed. No targeting radars were locked. This was communication through proximity. But proximity creates vulnerability. At this range, if the Tu-160 had been equipped with air-to-air missiles, it could have engaged the F-35 before the Norwegian pilot could react. The Tu-160 is not primarily an air superiority platform, but it can be equipped with self-defense weapons. The Norwegian pilot was betting that the Russian crew would not escalate to weapons employment. That bet was based on doctrine, not certainty. Doctrine assumes rational actors following established rules of engagement. But doctrine can fail when political pressure, miscommunication, or technical malfunction introduces unpredictability into the equation. The F-35 pilot was flying at the edge of calculated risk. Simultaneously, the United States Navy deployed its most sophisticated electronic warfare asset into the battlespace. An EA-18G Growler electronic attack aircraft launched from the USS Gerald R. Ford began orbiting at the southern edge of the intercept zone. The Growler carries the AN/ALQ-99 tactical jamming system, pods that can emit high-power radio frequency energy across a wide spectrum of frequencies. The mission was not to blind the Tu-160s. The mission was to demonstrate jamming capability. At 1000 hours, the Growler briefly activated its jamming pods, creating a burst of electronic noise that temporarily degraded the Russian bomber's radar and communication systems. The effect lasted less than 30 seconds. It was enough to make the point. The message was clear. We can see you, and we can deny you the ability to see us if we choose to escalate. The Russian response was equally calculated. At 10:02 hours, the Tu-160s activated their tail-mounted radar warning receivers and began broadcasting on NATO guard frequencies, the international emergency channels monitored by all military and civilian aircraft. The transmission was in English. NATO interceptors. This is Russian Federation strategic aviation, conducting lawful transit through international airspace. Request you maintain safe separation distance per international aviation protocols. This was not a distress call. This was a legal assertion. By broadcasting in English on guard frequency, the Russians were creating a recorded communication trail that would support their claim of lawful conduct if the incident escalated to diplomatic or legal review. Every word was scripted. Every pause was calculated. Here is what most people miss. The bombers were never going to penetrate NATO airspace. The entire flight was a reconnaissance in force, a deliberate provocation designed to map NATO sensor coverage, measure response times, and observe coordination procedures between allied nations. The Iranians aboard were taking notes. The Russians were recording radar signals, and NATO was learning just as much about Russian operational patterns. This was mutual intelligence collection, disguised as a confrontation. Both sides wanted the intercept to happen because both sides gained valuable information from the encounter. At 10:15 hours, the Tu-160s reached their farthest point of advance and began a wide banking turn to the northeast, heading back toward Russian-controlled airspace. The Norwegian F-35s maintained escort position throughout the turn, on ensuring the bombers did not deviate toward NATO territory. The United States Air Force Boeing A-3 Sentry continued tracking until the Russian formation was 200 kilometers inside Russian airspace and descending toward landing. The entire provocation lasted 1 hour and 47 minutes from detection to disengagement. No weapons were fired, no airspace was violated, but the message had been delivered and received on both sides. Now, this is where the kill chain bends. The decision tree for responding to this kind of provocation is not linear. It is a matrix of political, legal, and operational variables that must be evaluated simultaneously. If NATO had chosen to escalate, the options ranged from closer intercepts with weapons armed, to electronic attack that degrades bomber navigation systems, to kinetic interdiction using surface-to-air missiles. Each option carries different risks and different costs. Closer intercepts increase the chance of collision. Electronic attack can be interpreted as an act of war. Kinetic interdiction crosses the threshold into combat. The decision to maintain a non-escalatory posture was not weakness, it was strategic patience. The goal wasn't to win the engagement. The goal was to avoid creating a crisis that neither side wanted. But strategic patience has a price. Every time NATO chooses restraint, adversaries learn where the boundaries are and how far they can push before triggering a kinetic response. Over time, this creates a pattern of incremental escalation, where each provocation becomes slightly more aggressive than the last. The Russians fly a little closer. They broadcast on more frequencies. They bring third-party observers. Each step tests the limits of tolerance. The challenge for NATO is to maintain deterrence without overreacting to probes that are designed to trigger overreaction. This is the hidden cost of the information age. When every action is recorded, analyzed, and publicized, the pressure to demonstrate resolve increases. But resolve without restraint leads to accidents. And accidents in the Arctic can cascade into conflicts that no one intended. The Iranian dimension adds complexity. If Tehran gains insight into NATO air defense networks through these joint flights, it could use that knowledge to refine its own penetration tactics for regional conflicts in the Middle East. The Tu-160 flight profile over the Arctic is different from a potential strike profile over the Persian Gulf. But the underlying principles of sensor evasion, electronic warfare, and timing are transferable. This is why intelligence sharing between adversaries matters. It is not just about the specific flight. It is about the cumulative learning that occurs over repeated interactions. Every intercept is a training event for both sides. So what does this mean for the broader strategic picture? The Arctic is no longer a frozen wasteland. It is a contested domain where great powers project force, test boundaries, and signal intent. The melting of Arctic ice has opened new shipping routes and exposed new natural resources, increasing the strategic value of the region. Russia has invested heavily in Arctic military infrastructure, building new bases, deploying advanced air defense systems, and expanding its Northern Fleet submarine force. The United States has responded by increasing its own presence, deploying more attack submarines, conducting more freedom of navigation operations, and strengthening partnerships with Nordic allies. This competition creates a cycle of action and reaction, where each side's defensive measures are perceived as offensive threats by the other side. The biggest takeaway from this hypothetical intercept is not the technology. It is the decision architecture. Modern naval and air warfare is not about platforms. It is about networks. The F-35 fighter, the E-3 Sentry radar aircraft, the Virginia-class submarine, the Globus II ground radar, and the satellite constellation all function as nodes in a distributed sensor grid. The power of this network is not any single system. The power is the speed and accuracy with which information flows between systems. When the Norwegian radar detects a target, that data reaches the American Carrier Strike Group commander in seconds. When the American electronic warfare aircraft jams Russian communications, that action is coordinated with Norwegian interceptors to prevent friendly fire or confusion. This is sensor-to-shooter integration on a continental scale. But integration creates dependency. If one node in the network fails, the entire system degrades. If the fiber optic link between Norway and the NATO command center is severed, information flow slows. If the satellite constellation is degraded by jamming or anti-satellite weapons, over the horizon, targeting becomes impossible. The Russians and the Iranians understand this. That is why their provocations are designed not just to test defenses, but to map network architecture. Every radar pulse, every communication signal, every sensor track reveals a piece of the puzzle. Over time, adversaries can reconstruct the network and identify vulnerabilities. The hidden cost of transparency is predictability. This brings us to the three possible outcomes of this kind of encounter. First, de-escalation through signaling. Both sides demonstrate capability, exchange messages, and disengage without further provocation. This is what happened in this scenario. The Tu-160s turned back, NATO interceptors escorted them out, and the incident ended without shots fired. This outcome preserves stability and allows both sides to claim they defended their interests without escalating to conflict. Second, information advantage reshapes the battlefield. The intelligence gathered during the intercept allows one side to refine its tactics, improve its sensors, or adjust its doctrine in ways that create a lasting edge. This is a quiet victory that does not appear in headlines, but changes the balance of power over time. Third, logistics and geography become the silent winner. The side that can sustain presence in the Arctic, maintain readiness in extreme weather, and support operations across vast distances gains positional advantage that is difficult to counter. Infrastructure matters more than firepower in this domain. The reality is that none of these outcomes are permanent. The Arctic competition is ongoing. The next provocation will test a different boundary. The next intercept will involve different platforms. The cycle of probe and response continues because the underlying strategic drivers, resource competition, power projection, and alliance signaling, remain unresolved. The question is not whether NATO can defend the Arctic. The question is at what cost and for how long. In your opinion, after this calculated provocation, will Russia and Iran continue to expand their Arctic coordination? Or was this a one-time test designed to gather intelligence without committing to sustained operations? And if NATO maintains its current posture of restrained interception, does that preserve stability or invite further escalation? Share your strategic insights in the comments section, as we are eager to hear perspectives from analysts like you. If you think this breakdown has revealed the real dynamics behind Arctic air defense, consider engaging with the content and staying informed about future developments. Thank you for your attention. This video is for educational purposes only, based on publicly available information about strategic aviation capabilities, sensor networks, and Arctic defense doctrine. It is not operational advice and should not be used to plan harm or wrongdoing.